ભૂલી ગયો. હા એ બધું થાય. આજે તો આજ પણ નિવાન છે એટલે તમને વધુ જ વાત. Good morning, everyone. So let's continue from where we left the last time. It was that we had talked about that we had started talking about the VT graph, right? Okay, and I told you that if you have got a VT graph, then the slope of chord gives us average acceleration, right? Because that is delta V by delta T. And similarly, the slope of tangent gives you dV by dt, which is acceleration, right? So for VT graph, slope of chord is average acceleration and slope of tangent is instantaneous acceleration. Now, the last time we were, finally we were talking about these 2 points, right? Number 5 and number 6. I sent you these, right? But I think I did notice that when you all received it, the order was not, proper, right? The diagrams were at some, in some other order and everything. All right. So this is your chance over here. If you want to write it again, okay, these points, they are in this order, right? That would make more sense. Yes. Good morning, everyone. Okay. So we were talking about 5 and 6 actually, right? Okay. Yeah, sure. No problem, Preet. I'll just give you 2 minutes. All right. Okay. Write 1, 2, 3, and 4 first, and then we will talk about 5 and 6. Okay. Uh, Number 1 is about the XT graphs. Like I said, I didn't draw all of it again. All right, because there are 6 XT graphs, and what they were indicating, right? We have already talked about that, right? So you of course have to remember all the 6, right? It helps you following questions. Okay. Right. Okay. All right. Fine. Okay. All right. So now let's go to number 5 and number 6. So these two are actually about the area between the VT graph and the x-axis, right? So by finding the area between the VT graph and the x-axis. So what do we mean here? This is what we mean. Suppose, see, this is the diagram for number 5, right? So let's say this is green VT graph, all right? Again, it would work for any kind of shape, right? Does not have to be a straight line or anything, right? For works for any shape, all right? That's what we talked about last time. I've just drawn over here a diagram, so that will help you with that, right? So I'm saying that suppose this green is the VT graph. So like for example, first the velocity of object increase, then it decrease, becomes 0, decrease, like that. Okay, it changes, no problem. It is non-uniform, right? It is not constant. Still doesn't matter, right? So what we are having is that if I want to find what's the displacement of the object from time t1 to t2, right? So that is the interval. Time interval is from t1 to t2, all right? In that much time interval, if I want to find what is the displacement, then I should find the area. Okay, I'm reading it from here. Area between VT graph and x-axis. So I hope you have understood what I've marked over here. All right. Okay, I have marked the area between the VT graph and the x-axis, but only from time t1 to time t2. Is that clear? All right, only from time t1 to t2, right? And then if we consider this part of the this part of the area, this is above the axis, right? So that we are considering positive, but this is below the axis. So if we consider that as negative, then finally by adding everything out, right, okay, we will get the displacement. All right, that is what this point is, right? By using VT graph, if you get the total area here, okay, and here, right, but this area is considered negative because it is below the axis, then you get displacement from time t1 to time t2. But if you do it similarly and you consider all area positive, this one positive and this below axis also as positive, then you will not get displacement, then you will get path length. All right, from time t1 to time t2. Clear both the points 5 and 6? Okay, see, what we'll do is I will not repeat the explanation, instead we will solve a question. All right, so when we solve a question, you will see how we use it. All right, I think that would be better. Okay, right? So you'll be able to see how it actually is used, right? Again, see, I'm not giving you the proof right now. Why is it that you cannot understand the proof? You can, okay, but I'm keeping proof for the end of the chapter, because at that time we'll have to learn something new, right? Only then I'll be able to give you the proof. All right, so at the moment I'm not giving you the proof of this exact thing, right? So proof we'll talk about at the end of the chapter, right? Okay, so right now we'll just have to accept it, and here is a question. Okay, see, I've already drawn a VT graph, all right, for some moving object, right? This is a VT graph. Okay, all right, so let's read what the question says. Find the displacement and distance traveled by the particle in 10 second to 30 second. I hope you can read it. I'll just write 10 second to 30 second. All right, so what do we have to find? In the time interval from 10 second to 20 second, we have to find two things. First, displacement, that is delta x. Now see, listen to this very carefully. So far we have talked about only one formula that deals with displacement, and that is this, right? But you cannot find average velocity over here based on this graph. I repeat, based on this graph you cannot find average velocity. So what we'll have to do is we will have to use the graph. There is no other option, right? We cannot use this formula of average velocity. We must use this VT graph. All right, so what was that point? Displacement is nothing but area between VT graph and x-axis, right? And we have to consider the area below the axis as positive, sorry, above the axis as positive and below the axis as negative. All right, so we are going to use our point number 5. Clear? Okay, so let's start. First of all, from which time to which time? So you should put a boundary, right? You should put a boundary from which time to which time? From 10 second to 20 second. All right, so let's make a boundary. Here is 10 second. Sorry, 10 second to 30 second, excuse me. My concentration is not very good right now, I'm so sorry. 10 second to 30 second. All right, so here is 10 second. So this is that boundary. Is that fine? And then the final time is 30 seconds, so this is that boundary. All right, so do you realize I have to find two areas? This, okay, all right, let's call it area number 1, A1, okay, and let's call this area number 2, okay. But I want all of you to understand, that this area 2 is below the axis. So this is to be taken as negative and this is to be taken as positive. So when I will finally want to find the displacement, it will not be A1 plus A2. No, it will be actually this. Okay, it will be A1 minus A2. Is this clear? Okay, let's do it actually. Let's see what happens. First of all, can you all tell me what is A1? Can you all tell me what is A1 based on this graph? Based on the graph, can you tell me what is A1? Value, Ankita. What will be the area of that triangle? Okay, 15. Are you sure, Ananya? Kavya, 200. Sure about that? Gracie? Okay. All right, let's do it. Let's do it then. See, it is going to be half base. Base is 10 into altitude or height. Right? Half base into height. Okay. Clear? 100. All right. Yeah, 100. Fine. I hope it's clear for all of you. All right. So now minus. Now what's the area of that second triangle of this one? Can you tell me that? Come on. Make sure you do it right, people. See, everyone, I just want all of you to understand that this is going to be half base, that is 10 into 10, right? Area itself, A2 itself, this area, I repeat, this area itself is this, that, right? That is 50. But we are going to subtract it. Why are we going to subtract it? Point number 5, read about displacement. All right. How many of you, see, I want to know how many of you understood this whole thing completely? Can you please say yes or no? 100 minus 50. Read the point 5 also. How many of you understood that completely? Okay, Preet, what's your question? If you have not understood, Gracie, you have not understood, what's your question? Yes, Joy. Yes, Sanju, your question. I hope you are not, okay, I hope you are not trying to put minus over here. That's wrong, because height cannot be negative in that sense. All right. Okay, with the way you have learned it, see, if I take a triangle like this, right? Okay, and if I flip it and make it like this, do you think area will become negative? Do you think if you just turn it upside down, area becomes negative? Not at all, right? Okay, Harth, I've already sent the screenshots. Okay, I've already sent the screenshots. Avi, you will get any other shape, and in such cases you will have to do a lot more maths. All right, this is the easiest case. હજી તો હું તમને તમે સાવ નાના નાના છો એવી રીતે તમને કરાવું છું. Okay, you still have a long way to go. What is a square minus a raised to 1, Jay? I don't understand. Jay, I'm not clear. Okay, you mean to say A2 minus A1. Why should we have A2 minus A1? We don't have to do final minus initial, right? This is not a change or anything, all right? This is not a change, fine? Okay, this is just that we have to take total area, but this area is below the axis, so we are putting a minus sign in front of it, all right? Okay, so finally this answer will be 50. What will be the unit? What will be the unit, people? What will be the unit of this? what will be the unit? No, Falak, you're actually wrong. I mean, it's not that people want the proof. It's just that the procedure is not clear, or some of them are having some problems with area of triangle and all that. Okay, right? Let me tell you that proof is not going to be, like a walk in the park. Okay, many of you will have trouble with proof also. Okay, no problem. I can understand, right? I can understand. Don't worry. I will definitely give you the proof, right? That's why I'm not going to omit the proof, right? There are some students like me who can never do without the proof. Okay, so this is 50 meter. All right. Okay, so let's do one thing. Let's erase all of this, right? We have made a big mess of this. Okay, I'll just copy this diagram and then we'll find path length separately. Okay, yeah, right, there we go. So now we have to find path length. All right. See, we have already found displacement, and it turned out to be A1 minus A2 because this is below the axis, right? And that was equal to 100 minus 50, so 50 meter. All right. Displacement has unit 50 meter, isn't it? Displacement, yeah, right? Now we have to find path length. Okay, what's the difference? You have to take all area positive. You have to take all area as positive. So here we don't have to consider this area as negative, right? We just have to consider that also as positive. So what will it be? A1 plus A2. Yes or no? Yes. Yes. Dhruvi, the unit is wrong. All right. Yes. So the answer is going to be 100 plus 50, right? So that is going to be 150 meter. Yeah. All right. Devanshi, please write the unit. Okay. So this is going to be 150 meter. Now, now, uh, it is that I will give you some idea of what happened here. See, have a look at this. Have a look at this. This is the graph again. I'm just going to draw the graph again very fast. All right. Okay. It's something like this, and then it's a line like this. Correct? Okay. Something of this kind. So what is really happening over here is that here in this part, up to this point, up to 20 second, as you can see, up to 20 second in this part, that is 0 to 20 second, the velocity is positive. Agreed? Because this is a VT graph, right? So 0 to 20 second, the velocity is positive. And then from 20 second to onwards, or 30 seconds, suppose if you want to say that, then the velocity is negative, right? From 20 second to 30 second, this graph is below the axis. It means like the velocity is negative, right? And over here the velocity is positive from 0 to 20 second, right? So what is happening is, I hope you remember this sentence: object moves in direction of velocity. Correct? Object moves in direction of velocity, isn't it? So what we have is that, for suppose, let's say this is that number line on which object is moving. All right, let's say here is origin. Suppose object started from anywhere, right? Let's say from origin, doesn't matter. So then up to 20 seconds, right? For 0 to 20 seconds, the velocity is positive. It means the object or the person is moving towards, let's say, the positive side or right side. Okay. So then, right, we have to find the displacement from 10 to 20 seconds, correct? So suppose here somewhere is 10 seconds. So here also the velocity is positive. So in 10 to 20 seconds, the object is moving towards the right side, direction of velocity, positive, right side. So let's say the person walks 100 meter. Okay. But then after 20 seconds, the velocity becomes negative, right? Graph is moving down. So what does that mean? Sahil, graph is moving down. What does that mean? So let's continue with our discussion. It is that in 0 to 20 seconds, the object is moving towards positive direction and moves by 100 meter. That is what A1 is. That's what we have found. And then from there, the object moves in negative direction because velocity becomes negative from here. So then that means this person moves 50 meter back. That is A2. And now finally is over here, right? So what we have is, you could think of it like this is initial position and this is final position, right? But the object went like this 100 meter and then came back by 50 meter. So how much is the displacement? Can you tell me that? 100 meter right and then 50 meter left. So how much will be the displacement? This is 0. So this will be 50, correct? Yes. See, we have related the graph with what we already know. Yes, 100. Actually, the displacement the displacement is going to be final position minus initial position. So that is 50 minus 0 because this is initial and this is final, right? But anyhow you do it, whether you do it by drawing this kind of diagram or you do it by using this graph and doing this calculation, the final value is still the same. I hope you are seeing that, right? So what this indicates is in this portion the object moves right side, and then from here to here the object moves left side because here the velocity is negative, and that's why we were considering this as negative if you want to find displacement, right? But now in path length, I'm sure you understand that in path length 100 meter right side and then 50 meter back is actually 150 meter path length, isn't it? Right? So there you should only add, you should not subtract, correct? So hopefully you have understood this slightly better now. This is still not the proof again, right? But now hopefully you have understood what's happening over there, right? Why are we taking this area as negative in this case for displacement? Because this is towards the left side and this is towards the right side, correct? Over here this is path length, it is scalar, it has no direction, so you just have to add, right? I hope that makes sense. Okay, then. Fine. So that's about this thing, right? Now, it's not that always you will get straight lines or such things. Okay, yeah, it's possible that it's any weird shape, right? So how to do it in such a case and all that, we will talk about it at the end. All right, that's what I'm leaving it for the end. Okay, there you will get the proof also. All right, now we're going over to the next thing. So please remember these points. Area under area between VT graph and x-axis gives us displacement and distance traveled both. If you take everything positive, you get distance traveled, and if you take above axis positive and below axis negative, you get displacement, right? So that's what we have talked about. Now let's go to one very special and very common and very important case of this chapter, right? And that is motion with uniform acceleration. Okay, or you could also say uniformly accelerated motion. All right. Okay, so see, this is clearly telling us that here we are going to have acceleration is constant. All right, we're going to have acceleration is constant. Yes, like those graphs, right? Which were parabola. Now, see, I'm saying it's constant. I don't know whether positive or negative, all right? So that we'll worry about later, okay? So now, first of all, before we proceed with anything, before we proceed with this, I just want all of you to understand one simple mathematics idea, okay? So I'm putting it in a box. It's that if something is constant, then its average is also the same value, right? So what do I mean by this? What do I mean by this? What is the average of, can you find the average or mean? Okay, actually I don't want to call it mean, right? Let's call it average only. Suppose you want to find the average of 1, 4 and 5. How much is it? How much is the average of 1, 4 and 5? Okay, very good. I've got some right and some wrong answers. People be slightly careful here. Very good. The answer is 10 by 3, isn't it? All right. 10 by 3, of course. No, Vedant. All right. Now, instead of this, if I tell you that, suppose we find average of your marks, right, in some 3 exams or 3 tests, and in every test you got 80 out of 100. What's the average? No, Ria. I want the average. All right. Yes. Average. Yes. Very good. 80. Right. Because it's simply going to be 80 plus 80 plus 80 by 3, isn't it? So that's 80. So this is that sentence. Read it. Read this sentence now. So what I'm saying is that here all the values are same. That is constant. You could say that your marks are constant. Constant, that is not changing. So in such a case, the average is also the same value. Agreed? Is this sentence clear? Yes or no? All right, very good. Fine. So keep that in mind now. Okay, this applies not just to your marks, it's applicable to everything. All right. Okay. Now, so let's move ahead. So here we are going to talk about constant acceleration, right? Therefore, yes or no? Same thing, right? If something is a constant, if something is a constant, then its average is also the same, right? Okay. So now, keeping this in mind, we are going to derive some important relations. All right, let's start. Let's derive some important relations. First of all, average acceleration formula. People, I'm waiting for you. What's the formula of average acceleration? Hurry up. Hurry up, hurry up. What is the formula of average acceleration? No, Ria. No, Haley, that's wrong. No, Har. Yes, Ankita, well done. No, Rohan. Ami, well done. Tamanna, correct. No, Resha, it's wrong. Yes, Rahul, correct, correct. No, Chintan. All right. So the correct formula is delta V by delta T. All right, isn't it? Yeah, delta V by delta T. So this is equal to A, right? See, this is a special case. Don't forget, this is a special case. Why is it special case? Because acceleration is constant. Otherwise, this is not how it works, right? It's that we have put this value and this comes directly. All right. Okay. So based on this, I can write V2 minus V1 upon, right? This is what we can do, correct? But now I'm going to change the symbols a little bit. See, okay, look at this very carefully. Let's say that this is a VT graph. Okay, I'm drawing a VT graph. You also draw it in your notebook. All right. This VT graph is going to be a straight line. Because, why is it a straight line? Because acceleration is constant, right? The slope should be constant, because slope for VT graph is giving, I mean, slope of chord is giving average acceleration, and slope of tangent is giving instantaneous acceleration. So I'm saying that suppose when time is 0, the velocity is v0. I repeat, suppose when time is 0, velocity is v0. So I'm saying that let initial time t1 be equal to 0, right? See, we can start our watch or clock at any time, right? Correct? You have a stopwatch in your hand and you are observing motion. So whenever you start observing, at that time you put t equal to 0, right? So that's t1 equal to 0. And let final time, suppose final time t2, we call it to be t. See, what's the advantage of doing this? We are just making it very simple to write. Okay. So what we are having is now that suppose here at some time t, t is equal to t over here. All right, time is equal to t. Now at that point, suppose the velocity is v. Okay, so this v and v0 are also very nice symbols. Initial velocity is v0 again, right? Initial means at start, that is at t equal to 0, right? And final velocity is v, right? What's the final time? T equal to t. Again this time 0 time is initial time, and this time final time. All right. So then if I will put these values, listen to this very carefully. If I will put these values, then this equation that I've written over here, this one, will change as follows. See, I've only changed the symbols actually. Meanings have not changed at all, right? So instead of V2, V2 stands for final velocity, correct? So what's the final velocity? What are we going to write? V minus. V1 stands for initial velocity. So what is the initial velocity? V0 divided by T2. T2 for final time. t minus t1 initial time, put it equal to 0. Is this step clear? Yes or no? We have only changed the symbols, right? We are still using the same equation that we did earlier, right? What we have done is that we are changing the symbols, right, as follows. I'm just making a little table that will help you. This is initial values, right, and this is final. So far we were writing initial velocity as v1, but instead of v1 now I'm writing v0. Okay, we were writing final velocity as v2. Instead of v2 I'm writing v. Similarly, instead of initial time we were writing t1. Instead of that I'm putting t1 is equal to 0, because you can start your stopwatch at any point of time, right? It's not like someone will say, okay, that's not allowed, right? When you are observing, you could call any time as 0, just like you can take any position as a reference point. Okay, and then finally over here in t2 we are just calling it t, because one time we have already put as 0, so you don't need to worry about anything, right? So ultimately this will become this equation when we put all the 4 values. So now, okay, so this is what we have got. V minus v0 is equal to at, because t minus 0 is t, multiplying it on that side. So finally, right, this is an equation that we have got. See, you learned about this earlier in 9th standard also. You may be remembering this. No, Raj, initial velocity is not 0. Yeah, it's the same actually. Forum, it's exactly the same, right? Only that we are using slightly different symbols. Meaning is exactly the same. In 9th standard, you used to use this as initial velocity, right? So here we are using v0 as initial velocity, right? And everything else is same. Exactly, Sahil. We are going to derive all the 3. Okay, so this is the first one. This is the first one. For people getting confused, see, I'd say don't worry about it. Even if you will start from here, right, and you don't do anything at all, then also you will get the same relation, but you should understand the difference. The difference will be as follows. This is what you will get, right? It's the same relation. The thing is here, what was t? Here t was time, interval, right? Okay, I'll just stop over here. I'll not confuse anyone out by giving multiple methods. It will make it very tough, right? Okay, so again, I will talk about this second thing a little bit later, right? Or for anyone who would still have a problem, you could ask me personally, no problem with that. So I was saying that we just have this relation, we change the symbols, right? This is changing of symbols, right? Okay, meaning has not changed. So this is the first equation, all right? It's just like what you learned in 9. Let's go to next, second one. Now for the second one, this is not the proof of what we learned earlier, right? This is a derivation, and you have to remember, I mean, you have to learn how to derive it. Okay, so yes, this is like a theorem. You have to learn how to derive it. Okay, don't mug it up. All right. The second thing is about displacement. Suppose we want to find out how much is the displacement in time t equal to 0 to t equal to t, right? In this time interval, how much is the displacement? So we are going to use the VT graph, right? Because we have drawn a VT graph, we're going to use the VT graph, right? Okay. And from VT graph, displacement is nothing but area between VT graph and x-axis, right? No, Arkan, I think in ninth also you'd have had similar, right? But at that time you were probably a little bit younger, so you didn't know a lot of maths and everything. That's why, right? Okay, so displacement area between VT graph and x-axis. Let's have a look at the graph. Okay, here is the graph. All right. Okay. So which area do I have to find? From t equal to 0 to t equal to t, right? So do you see it's like a trapezium? Agreed? This area is like a trapezium. Okay, I want to know. I want to know how many of you do you know what is the area of trapezium? Do you know the formula of area of trapezium? Formula for area of trapezium. How many of you know that? Can you please write it if you know? Okay. If you don't know, no problem. I'll try by another method. Okay. It's not like this is a big trouble if you don't know. How many of you know the formula of area of trapezium? Okay. All right. All right. Okay then. So some of you do know and some of you don't. It's into height, Falak. Okay. So out of all the people that they have sent, most of you know the formula, all right? No, it's not base into height. That's a rectangle. Okay. So generally you seem to know it, all right? But still, for people who might not be knowing it, I will I will write it here. See, this is how it works. Formula of area of trapezium is as follows. It is half into sum of length of parallel sides. Okay, I'm writing it in words because that way it's actually easier in my opinion. Multiplied by distance between them. Between them means between parallel sides, all right? Them means parallel sides. So what do I mean? If we have got a trapezium like this, for example, right? Let's say this is A and B and C and D. Then we have AD parallel to CB, right? Okay, so then this formula will become 1 by 2 into AD plus CB because they are parallel sides. AD, CB, right? Into distance between them. Distance between which sides? AD and CB. So how much is that distance? This much distance. All right. Okay, that much distance. So that will be equal to CD. All right. So this is how you do it. Clear? Yeah. Yes, this can also be done by area of triangle plus area of rectangle. All right. So this for people who want to do it like this. Okay. Right. For anyone else, if you have a look at this, suppose this is a parallelogram. You can clearly see that, right? This area under the graph is this, right? So we have to find this area. So you can clearly see that this is a trapezium, and that trapezium can be converted into one triangle and one rectangle by drawing a line like this. Agreed? Right? So now we can easily find the area, right? Even in such a case. Okay? All right? So let's do it. So those who want to do it by trapezium, I don't mind. Those who don't want to do it by trapezium, you follow what I'm doing, right? So I'm going to say that this is O, A, B, C, and this is D, right? So now this whole area is this area 1, or sorry, area of that triangle and area of this rectangle. All right. So this is equal to area of triangle ADB plus area of parallelogram OABC, right? Okay. Can you see it here? Which area? Area of this triangle plus area of rectangle. Actually, I'm feeling very uncomfortable with this diagram being far away. I will just draw that diagram again very fast. All right. Just give me a moment so that we all don't have to look up and down every now and then, right? I know it's very irritating. All right. I'm so sorry. This is getting very clumsy now. Okay, fine. Let's go to the next page. Never mind. So what we have is a graph like this, right? Okay, and we know that here this is initial velocity v0 at time 0, and then there is another point here when time is t, right? And here the velocity is v. So now we have divided this trapezium into two parts, one triangle and another rectangle. So this is A, this is B, this is C, and this is D, right? So I'm saying that this displacement is area between this line and this x-axis, right? So that's why this should be area of triangle ADB plus area of rectangle OABC, right? So that's what we have. Now let's start. See, this is, listen to this carefully. This is initial velocity v0, and this is time t, and this is time 0. So this width, how much is this width? Can you tell me how much is this width? How much is the width? Very good, Raj. AB, but how much exactly? अरे AB થી કઈ ન થાય. Value, people. I want the value. Yes, correct. It is that this is t equal to 0, this is t equal to t, so this gap is t, correct? And this is 0 and v0 here. So how much is this? v0, correct? Very good, Nemi. Perfect. All right. So this is going to be plus. So look at this rectangle. What is its area now? What is its area? What is its area? Value of its area. Hurry up, come on, people. Value of the area of rectangle. Yes, Kavya? Very good. Yes, I think that's enough correct answers. Yes, it is V0T. Right? It is V0T. All right? And now this is equal to area of triangle ADB now. Okay, so we have to look for ADB. See, for that you need base. Base is already T. And we need height. This one. Can someone tell me what's this? Can you please tell me? Look at this. This is V0. and this is V. How much is BD? How much is BD? Yes, Ami, well done. Yes, Vishwa. Palok, it's right. Nandini, are you sure? Yes, Joy, well done. No, Ryan Khan. Ashish, it's wrong. Well done, Bhavya. Forum, are you sure about that? No, Gracie. No. અરે કેમ આવું થાય છે? Why are you people getting confused? People, look here. Everyone. Suppose here is one point B and here is one point D and this is 5 and this is 7. Then how much is this length? Oh boy. Rohan, 12? Eh? Yes, it has to be 2, right? Come on, people. Right? It has to be 2. It cannot be anything else. 7 minus 5. So like that here, it will be what? It will be V minus V0, right? I don't think anyone should have any problem with that now. Correct? So let's put it over there. So what will be area of this triangle? Look at this triangle. Half into base into altitude or height. Clear? I don't think anyone has any problem with that. Right? Okay. All right. Let's continue now. So we are going to simplify this, right? There's one more step that we are going to do. If you look at the first equation that we wrote was V equal to V0 plus 80. Yes, Arkan, do you have a question? Right? So what is V minus V0? What is V minus V0? Yes, that's right. Correct. So that's what we are going to put here. All right. So I'm just going to write that here. All right. So this is half into T into V minus, instead of V minus V0, 80. Right. This is because V minus V0 is equal to 80. So now we go to next step. Let's go to next step. Therefore, delta x is equal to V0t plus 1 by 2 a t into t square, right? So that's the second formula. All right. People, I would like that all of you write it as delta x equal to only. All right. No other symbol, please. Okay. Delta x is delta x. Delta x cannot be anything else, right? Everyone. I know in 9th standard you might have learned something like d is equal to v0t plus half a t square, or maybe s equal to v0t plus half a t square. I'd say no, don't use these, right? No, please don't. It is just like that, agreed. But writing delta x is very important because delta x indicates displacement, and displacement cannot be d and cannot be s, right? Clear? So please be careful. Okay. So now that's the second equation. We're just going to stop over here, right? Okay. I will give you hint for third, right? How to derive third, I'll give you hint, and then we'll derive it tomorrow. Let's see whether you can do it on your own. All right. Okay. So a little bit of challenging homework, right? So the hint is for third equation, you have to put or substitute, you have to substitute value of t from 1 into 2. So that is from 1, from equation 1 you find value of t. That is from this equation you find value of t, right? What is t? You find it from this equation, all right, and put that in second, all right, okay, and then try to derive the third, see what you get, all right. So that's your little homework, okay. Try to derive the third on your own, right? Okay, fine. So we will continue the next time, all right. Goodbye then.